Hello everyone. In this video lesson, I will be discussing the introduction to physics. And to be specific, I will discuss the concepts of scalar, vector quantities, and linear motion, including the concept of speed and velocity. I am your teacher, Mr. Mark Anthony B. Laroya. So let us now define what is physics. Physics is a branch of science that deals with the nature and properties of matter and energy and their interaction. So that means it's not just all about matter, but it pertains to the interaction of matter, energy, and nature. It also explains the physical processes and phenomena of a particular system. So it explains what really happens to a particular situation or system. Let's say, for instance, you throw an object upward. You may ask, why is an object falling back on the ground? Physics can explain that through the use of the concept of gravity. Physics covers different fields including mechanics, acoustics, optics, heat, electricity, magnetism, radiation, and atomic and nuclear sciences. Physics has a lot of fields and concerns involved. However, in this video, we're just going to discuss the basic concepts of physics. For example, the scalar and vector quantities and speed and velocity. So let us now start discussing the difference between a scalar and vector quantity or quantities. A scalar quantity is a physical quantity that can be described by a single element of a number such as real number and accompanied by a unit of measurement or what we call as magnitude. So let's say for example we have time. We can say that time is a scalar quantity because as we use time, let's say for example, you have 5 minutes, you quantify time with a particular number or numerical value, and then you have the unit of minutes. So you can also use 4 hours. So you have the numerical value 4 and the unit which is hours. And then for mass, as we all know, mass is the amount of matter. We can use, for example, you have 5 kilograms of an object. You quantify mass with a numerical value and its unit kilograms. Volume is also a scalar quantity. Sometimes volume is the product of length, width, and height, or sometimes it simply pertains to the space occupied by matter. For example, 500 ml, 2.5 milliliters. So that is volume, which is a scalar quantity. And also, we also have what we call the speed. Speed is a scalar quantity wherein it tells how fast or slow an object is moving. Let's say, for example, if you can see or if you have seen a speedometer in a vehicle, it tells you how fast or slow your vehicle or car is running. And these are all scalar quantities. Let us now talk about vector quantities. A vector quantity is a quantity that has both magnitude and a direction. Compared to scalar quantity, a vector quantity this time has a magnitude and also a direction. So for example, force is a vector quantity. A man is pushing a wheelbarrow with a force of 100 newtons to the right. So aside from giving the magnitude or amount of force, you also include the direction. We also have the velocity. Velocity is a vector quantity. When it comes to the concept of how fast or slow an object is moving, they're just the same with speed. However, the only difference is that velocity also describes the direction. So for example, a car is running at a velocity of 60 kilometers per hour towards south. So it includes magnitude and a direction. While for the momentum, momentum is simply the product of mass and velocity. Since it is comprised of a vector quantity, we can already consider that momentum is also a vector quantity. Let us now talk about what is kinematics. Kinematics is the study of motion without any reference to the forces that cause the motion. So meaning, we're just simply to study or discuss how things are moving and not why things are moving. So this includes the topic about displacement, distances, speed, velocity, and how do they vary in time. So before we begin discussing the concept of speed and velocity, let us first define linear motion. Linear motion, also called as rectilinear motion, is a one-dimensional motion along a straight line. So we're just simply talking about moving objects along straight line. So let us now talk about speed. Speed is distance over time. Speed is denoted by small s and distance for d for distance over t, and that is time. We can also use this formula distance over time for velocity. The units of speed would be meters per second if we're going to use meters as the unit of our distance and seconds for the unit of time. When it comes to other units that we can use for speed or velocity, we can also have kilometers per hour if we're going to use kilometer as the unit of distance and r or r's for the unit of time. Kilometer per hour, or also known as kph. Let us now solve a sample problem involving speed. A car traveled a total distance of 150 kilometers in 2.5 hours. What is the speed of the car? Consider that the car traveled with uniform motion or speed during the entire journey. So we were given the distance and the time of the car as it traveled for 2.5 hours with a distance of 150 kilometers. The formula for speed is distance over time. So all we have to do is to simply substitute the values of d and t to our given formula for speed. So this will become s is equal to 150 kilometers divided by 2.5 hours. So we will have speed is equal to 60 kilometers per hour or 60 kph. Another problem here. If the speed of the running car is 12 meters per second, how long will it take to reach a distance of 600 meters? So in this problem, the given are the speed of the car, which is 12 meters per second, and the distance covered by the car equals 600 meters. If we are asked of how long will it take, it means we are required to get the time. Time, this time, is equal to distance over speed, or that is t equals d over s. So we substitute the values of distance and speed. We have time is equal to 600 meters divided by 12 meters per second. So as you can see here, the unit of meters or meter will be cancelled and the remaining unit will be seconds, which is the unit of time. So our answer now would be time is equal to 50 seconds. So if the car is running at a speed of 12 meters per second, it will take 50 seconds to cover a total distance of 600 meters. And for our last problem here, determine the distance covered by a running car with a velocity of 20 meters per second towards north in 1.5 minutes. So if you notice, we are using the term velocity because we have a magnitude that is 20 meters per second and the direction towards north. So the given are the velocity that is equal to 20 meters per second and time of 1.5 minutes. And we are asked to get the distance covered by a running car, by the running car. The formula of distance here is velocity times time, or that is d equals v times t. However, we cannot yet do this directly or substitute the values directly because of inconsistency in units. For velocity, we use meter per second. The element of time is in terms of second, while the given time is in terms of minutes. So first, we must convert our time into seconds. 1.5 minutes is equal to 90 seconds. So we can now use this value, the 90 seconds, as our time to our given formula of the distance. And that is, distance is equal to 20 meters per second times 90 seconds. So the unit of time, seconds, will be cancelled and we will have the answer distance is equal to 1,800 meters. So this is the summary of formulas for speed or velocity, that is equal to distance over time. For distance, that is speed times time, and time is equal to distance over speed. Thank you very much for watching and listening, and I hope you learned something new about physics, more specifically about speed and velocity. See you again next time.